In this section, we will take a look at what is known as profiling engine of the Identity Services Engine, which is a special component, a special software component used by ISE to perform endpoint detection and classification. With the profiling engine enabled, what we will be able to see exactly on the in the network is going to be a type of the connecting endpoint, and also in some cases the localization, or just the place from endpoint connects, like for example a switch port of a given switch, or maybe an access point through which a association was established. So this way we will eventually improve visibility of the network. We will be able to distinguish between individual types of devices connecting. And now the profiling engine is gonna perform its function by relying on two main components, one of which is going to be known as profiling probes, and the other one is going to be known as profiling policies. Okay, profiling probes is something that we will use to analyze received network communication, where the goal is going to be to collect this information and then divide it into so-called attributes of the endpoint. And then in the next step, once the attributes were collected, we will kind of like sift those attributes for our policies to figure out which of the policies are a match, and this way be able to determine what's the profile of the connecting endpoint. So in the first step, we will be collecting attributes, and then in the second step, we will be analyzing them, matching them against our profiling policies. Now, technically, individual rules that policies are made of. And now, the main reason why we might want to use something like this, why we might want to enable the profiling engine, is going to be the enhanced visibility into the environment. Because with a profiling in place, we will be able to distinguish between, as I said, types of devices connecting. Like I might be able to tell that device with MAC address X is an Apple iPhone versus device with MAC address Y is, let's say, a Cisco IP phone. So with this information in place, I may be then able to use it in my authorization policies, and this way come up with much more accurate rules and eventually build more secure, more accurate policies in my network. For instance, you might want to build a policy that changes the access that will be granted to the user based on the underlying device used for the session. Like when Kate connects from a corporate laptop, she will get full access to the network, versus when she connects from her personal iPhone, she will be only able to get to the mail server and maybe get to the internet, but not anything else. And just to give you some more insight into the process, or just how profiling is implemented on the ISE, it will consist of several steps. In the first step, as I briefly mentioned, the goal is going to be to analyze network communication traffic received from the network, where in most cases what we will be analyzing is going to be management plane packets like SNMP, like DHCP, like DNS, maybe radius. So stuff like that is going to be used in pretty much every single network, and the goal is going to be just to deliver those packets to ISE so it can analyze them. And now once we have those packets, we will be shifting them to the profiling probe so that the probe can tell exactly what type of information endpoints are associated with. So attributes is what the profiling probe is gonna try to extract from the packets. But in addition to that, we will also always want to correlate those attributes with an address, because we have to know which attributes belong to what endpoints. And this is exactly where the address information is gonna come into play. So in general, our endpoints will be identified through their MAC addresses. The MAC address is supposed to be unique in the network, and this information will allow us to distinguish between the endpoints also in the endpoint profiling endpoint database. But in some cases, it is also going to be an IP address, or ideally what we will try to achieve is going to be to have both addresses, the physical and logical address of an endpoint. And the reason for this is that some profiling probes will not be able to correlate attributes collected for the device if they don't have a matching entry in the endpoint database. Okay, so the situation is going to be pretty straightforward with physical addresses, with MAC addresses, because this is what populates the endpoint database. But if we get, let's say, information for an IP address but not MAC address, the collected attributes might be lost. I will get back to this concept in just a minute. Once we have those attributes and we were able to associate them with our endpoints, in the next step, we're going to update our database. So for example, if this was a new device that is connecting to the network for the first time, we will add an entry to the endpoint database. We will add its MAC address, possibly also IP address if both of those addresses were collected, and we will then bind those addresses to the collected attributes. Okay, and finally, what is going to happen is that those attributes that are in the database will be then evaluated against our profiling policies. There are multiple profiling policies available on ISE, and the goal is going to be to find at least one matching policy, and this way be able to tell what kind of a device we are talking about, we are seeing in the network. As a result of this last step, in most cases we will find a profile for the device, or maybe if the device was already profiled, we just collected some more attributes for the endpoint, we will be able to find a new profile for the device, which is known as reprofiling. So we might be able to either assign a new profile to the new endpoint that was detected for the first time, or we will simply update the device's profile. In few cases, our identity services engine will not be able to find a match, in which case the device is going to be assigned to an unknown profile. Okay, so just to give you a high-level overview of this process, let's take a look at this on an example. I'm going to say that we will focus on this single PC, which is going to be using a physical MAC address of A. This is going to be MAC address of this PC. And we will also say that at this point, we don't really know what is the IP address that will be used for this device. I'm only going to say that this connection is going to be authenticated with 802.1x, which means that our switch is going to be sending radius packets to identity services engine to perform authentication and authorization of this PC. This is going to be radius packets. Okay, so this is an equivalent of our step number 1 from the slide. We are sending some data packets to ISE, and now assuming that radius probe was enabled on our identity services engine, which we will say it was, I'm going to say that the radius probe is enabled. This packet will be now analyzed by the probe, where the goal is going to be to obtain the information about the connecting endpoint, find its attributes. And now, as I said, the packet that is being analyzed by the probe is going to be kind of like broken down into two sections. I mean, the information from the packet. So this is our radius message from the switch. In the first portion, we will have what is known as the address of the connecting endpoint, or addresses. Or in the second portion of this message, we will have our attributes. So this is exactly what the radius probe is trying to do. It is trying to find these two pieces of information, an address and attributes. Now in our case, we know that the address of the connecting PC is A. This information is going to be included in the radius message. But MAC address on its own is also an attribute, because of the fact that every single MAC address consists of two portions. We have what is known as OUI, organizationally unique identifier, followed by the actual identifier of the network card. So this is the first 24 bits of the MAC, what corresponds to a vendor or just manufacturer of a given NIC. So we will know immediately, well, assuming that this PC was built by Apple, we will know immediately that this is an Apple device. So this is what I assume. I assume that this PC was manufactured by Apple, just for the sake of this discussion. And now, as a result of that, we have two pieces of information found by the radius probe, an address and the attribute, the one attribute as of right now. So in the next step, what ISE is going to do is that it will put this information, it will make an update to the endpoint database.